And I am going to pick a leadership team of 3. So I'm going to pick 3 of you, and you're going to be my leadership team. Right? That's the first problem. The second one is same class, but now I'm going to pick a president, a vice president, and a treasurer. So both cases, there are 10 kids in the class, and I'm going to choose 3 of them. Are those the same problem, or are they different problems? What do you think? So again, in the first case, there's 10 of you here, and I'm going to pick 3 of you to be the leadership team. You're going to be the leaders of the class. In the other problem, problem 2, I'm going to pick a president, a vice president, and a treasurer. Or a president, a vice president, and treasurer. Are they the same problem? Both involve 10 kids choosing 3, right? What's different? The second one involves assigning specific tasks to those people. So in the first one, in the first problem, if I pick her, him, and her, would that be any different than picking her, and him in the first problem? No. So in the first problem, order doesn't matter. Thank you. Order doesn't matter. When you are choosing things, when you have a group of objects or a group of people or a group of whatever, and you are choosing them, the first thing you have to get straight in your mind is, does the order I choose them matter? And if the order does not matter, this would be an example of that. The order does not matter. So I'll write no order. You have what's called a combination problem. And the notation that we would use for that, in this case, is 10C3. The C stands for combination. What do you think that 10 stands for? The amount of people I have to pick from. And then 3 is the number of people that I am actually picking. Sometimes in some books, and you never know what book you're going to have, it's written that way. It's exactly the same thing. Okay?
Are those like subscripts?
Yes, those are subscripts. Those are definitely, in this notation, they are definitely subscripts.
Okay, does that say, what is it? How many what?
Slates. But wait, we're not there yet.
Okay.
So just wait. We're still talking about this one. It's a big idea. This notion of combinations. Combinations are choices that you make where order doesn't matter. All right, get your calculators out. You actually can calculate this real easy on your calculator. See, back in the day, I had to do it by hand, and I'll show you how to do it by hand also, because once in a while we have to do that if there are letters involved instead of numbers. But right now, let's type this in on our calculator. So we press math, which is like the 3rd button down. Notice you have options across the top. Go to prob. And if you look down that list, you see an NCR button. All right, so here's how it works. Go back to your home screen. Nope, not yet. You gotta go back to your home screen. Type in the first number, so type in 10. And then go to your NCR button, so hit math, across to prob, down to NCR, hit enter then. Then type in your 3, hit enter, and it should give you the answer. What does it say? What is it? 120. So the answer is 120. Okay, so where is our combinations button? It is in the math prob menu. Okay? What?
Does it matter if our things are radians or degrees?
Yeah, it has nothing to do with what we're doing here. Nothing at all. That only matters when you're dealing with angles, when you're inputting or outputting angles. Okay, now, there is a formula for this. I'm going to show you what that is. You may never have to use it. There are some problems in the book where you have to do combinations, and instead of 10C3, it's like SCT. And so you obviously can't type that on a calculator, so you have to know the formula. I don't know if she's going to assign them or not. The formula for this would be 10 factorial over 3 factorial, 7 factorial. Now, I don't think you have any question about where the 10 came, right? You shouldn't have any question about where the 3 came from. Where did the 7 come
The
from?
remainder?
It's the difference of the 2. That's right, 10 minus 7. So if we had, you know, 12C8, and we had to do it by hand,
So it'd be 12
factorial,
factorial over 8 factorial 4 factorial.
that's it. Okay, if you have to do it by hand. If you don't have to do it by hand, use your NCR button, right? Just type it in. All right, so now we're coming to problem number 2, which you said was different. By a slate of officers, I mean like a ballot. So I got president, vice president, treasurer. That would be one slate. President, vice president, treasurer would be another slate. Now the order matters, because if I pick you first for my team, if I pick you first, you are going to be the president, right? And that's different than if I pick you second and you are the vice president. So here, order matters. Order matters. Spell it right. That's called a permutation. And I bet you can guess the notation we're going to use is exactly the same, except we're going to use a P. The P tells me that order matters. The order of choice matters. Well, guess what? You got that button on your calculator too, and it's in the same place. You do it the same way. So you have to put your 10 in first, and then go to math, across to prob, down to NPR, hit 3 and equals, and what's the answer to that one? 720. If you ever have to do that by hand, the formula for permutations is 10 factorial over 7 factorial. So in other words, it's the total over the difference. It's the total over the difference if you ever have to do it by hand. Otherwise, you're just going to do it on your calculator.
So if you just typed in 10 factorial over 7 factorial,
It would give you 720. And that makes sense if you think about it, because what's 10 factorial? 10 times 9 times 8 times 7 times 6, da 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 da. And what's 7 factorial?
7.
6 times 7.
Oh, do they just cancel?
They just cancel. And you're left with 10 times 9 times 8, which is 720. Okay, here we go. Now these two. Same class of 10. Only now, I'm going to pick 4 of you to give a pencil to. Or, that's one problem. The other problem is, I'm going to pick 4 of you to give a marker, a pencil, a calculator, and an eraser. So, both of these situations involve me choosing 4 of you and giving you a prize. Right? So, are they the same?
No, because those are identical.
And what makes the difference if they're identical or not?
They're grouped together.
If you are in problem number 3, does it matter if I pick you first, second, third, or fourth?
No.
You don't care. You're going to get a pencil one way or the other, right? So it doesn't matter to you. But what if you're in the last problem there? Wouldn't you care when you got picked? Because wouldn't you rather have a calculator than an eraser? So you want, the order you get picked matters, right? If the order of choice does not matter in number 3, it does not matter. So your setup for number 3 would be what? 10 C4. Order does not matter. When you pick a leadership team, or you're giving everybody the same prize, there's no specificity. There's no specific position for anybody. It doesn't matter, just pick me. This one, if I'm going to give away a marker, pencil, calculator, and eraser, this one's going to be 10P4 because I'm giving you specific prizes. So the order that you get chosen is going to matter.
How did you get the 4 again?
I'm giving away 4 prizes.
Oh.
So 4 kids are getting prizes. Or there are 4 pencils, whatever. Remember, the first number is how many you're picking from, and the second number is how many you're picking. I'm giving away 4 prizes, so I'm picking 4 people. All right, get your packets out now. We're going to do a couple.
Should have any extra packets? I'll just-
First of all, I am the sub. How in the world do I have extra packets for your class? I don't. Take a picture of somebody's. Just take a picture. I'm sure she's got one for you, but I don't. Okay, the first, I'm on page 3. Page 3. So this is the packet we used last time I was with you. There were only 6 of you that day. Are you the only 6 that have the packet? Did the rest of you not get it? Okay, take a picture. Everybody needs to take a picture. I was
Use my
going.
phone, take a picture.
Huh? Yeah, you can use your phone. Yeah. Or your iPad or something. She has the extras on her card. I guess she forgot to hand them out. So the 6 of you that were here, can you let somebody take a picture of yours, please? All right, we're going to do all the problems on this page. This is page 3 now, page 3. We're going to do all the problems on this page, but we're going to start with 3, 4, 5, and 6 because they are what we're talking about right now. The other 2 are kind of reviewed. So number 3, here we go. How many committees of 5 can be made from a group of 12? So obviously it's 12, and we're picking 5. So what do you have to decide? Before you circle one of these, you have to decide what? If the order matters. What are you doing? You're picking a committee of 5. Does order matter? No. So you will circle 12C5. 12C5. When you are picking a committee, it does not matter when you get picked. You just want to get picked. All right, number 4. I'm going to give away a calculator, a pencil, and an eraser to 3 people in a class of 20. That's 20 P3. Because the prizes are different. If the prizes had all been erasers, then it wouldn't matter, right? That would be 20 C3. But since we have specific prizes, we're going with the P. How many different 5-card hands are possible from a standard deck? Okay, so we got 52 cards in the deck. We're picking 5 of them. Here we go. How many different hands would be possible? Is that a P or a C? That's a C. That's a C. We're talking about a different hand of cards. The order you arrange them is not important. You got these 5 cards, so that's 52 C5. Now, 6 you have to do by yourself. Okay? We're going to set this one up. Here we go. Let's see if you have a thought. How many 5-card hands contain 3 diamonds and 2 clubs? So 5-card hands containing 3 diamonds and 2 clubs. This going to be a P problem or a C problem?
P. C.
I think it's going to be a C because I don't really care what order I get them. I just want to end up with those cards, right? Okay. Anybody have an idea? It is going to be a C problem.
52C12.
What'd you say?
I said 52C12.
All right, let's talk about that.
Would it be 52?
That would mean there were 52 cards in the deck, which there are, and I'm going to choose 12 of them.
10.
Am I choosing 12 of them? No. How many am I choosing?
5.
5. So, all right, so let's talk about this. Now, this says there are 52 cards. Pretend I have a bucket here. There's 52 cards. The whole deck is in the bucket. And I'm just going to reach in and grab 5 of them out. that what I wanna have happen? Or what do I wanna have happen? I wanna get 3 diamonds. Okay, now, so wait a minute. Instead of choosing from the whole bucket, if I wanna get 3 diamonds, what am I gonna choose from? 13. I'm gonna choose 13C3. That takes care of my diamonds. If I have to get a diamond, then I cannot pick from the whole deck, you guys. Does that make sense to you? If you must get diamonds, then you have to pick from the diamond pile.
Okay.
And there's 13 cards in the diamond pile, right? Okay, am I done? No. Because what else do I want? I have to get 2 clubs. 13C2. Now, this is all the different ways I can pick 3 diamonds, and this is all the different ways I can pick 2 clubs. Now, and I know I could type both of these in. I know I could get these numbers. They're just numbers. What would I do with those 2 numbers? Multiply. And here's how you know, if you guys haven't talked about this already, this is big. You need to make a note of this. When you are picking diamonds and clubs, whenever you are doing this and this, it's a multiply. If I said, how many ways can I get 2 diamonds and 2 hearts, or 3 diamonds and 2 hearts, this would be an add. So I would do this problem, which would be 13C2 times 13C2. 2 diamonds, 2 hearts. Does that make sense to you? Or 3 diamonds, 2 hearts. And then I would add those 2 together. So what's the big deal here? What am I trying to get across here? And if you're doing them at the same time, if it's this and this, it's always multiply. So if I'm gonna pick Republicans and Democrats, I'm gonna multiply. If I'm picking Republicans or Democrats, I'm going to add. That's in every problem. Okay, C's, P's, factorials, any problem. If you're doing them together, it's a multiply, an and is a multiply, and or is an add. Okay, got it? Okay, now the little bonus at the bottom, what does the P stand for? I erased it. Who remembers the vocabulary word? The P stands for permutation. So when someone, mathematician, talks to you about permutations, you know they're talking about choices where order matters. All right, we're going to do some more, but let's go up and finish this page. How many outfits can I make with 3 jumpers and 4 shirts if every shirt can be worn with every jumper? 12. Perfect. Beautiful. 3 times 4. Why am I multiplying? Because I'm picking a shirt and a jumper, right? That's a multiply problem. How many license plates can be made that contain 3 letters followed by 2 digits if no digits can repeat, but the letters can repeat? So these can repeat, these cannot repeat. 26, 26, 26, I hear that. And 10, 9. Beautiful. What are you going to do with those 5 things? Multiply, 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 because you're picking a letter and a letter and a letter and a number and a number. Beautiful. Turn it over. Take a picture if you need it. Got a couple of quizzes back here.
Why'd you do just 10?
You're good.
Now what?
Why'd you do just 10?
What did you want me to do?
Why can't you do it 8 and 9?
8 and 9?
Yeah.
How many possible numbers are there to pick from if I'm going to choose a number to put in this spot? How many choices do I have? How many digits are there? 10. 0 through 9.
Oh, yeah.
Right? So there's 10 digits. but they're not allowed to repeat. So once I put one here, now I only have 9 to choose from. Right? Okay, here we go. We might be able to do this one, although it does have a little tricky component. How many 5-card hands contain exactly 2 hearts? What do you think? 5 cards, I'm going to pick 5 cards, and I have to get 2 hearts. We'll start with that. You know that. How do I get 2 hearts? 13C2. That's 2 hearts, right? Now, why am I not done? Kids always forget this part of the problem. Because it's supposed to be a hand of 5. How many have I picked so far? 2? Now it says 2 have to be, exactly 2 have to be diamonds. What does that mean about the other 3? They're not diamonds, right? How many? 39. C3, beautiful, that is it. Where did the 39 come from? There are 13 hearts, 13 clubs, 13, what's the left, spades, right? Because we picked our 2 diamonds, and now we're going on. Do you want me to finish these quizzes, or?
Go ahead.
Yeah. I got a video going, so I thought I'd just finish up the quizzes, if that'll work. So you can go get organized. Oh, some of them don't have the packets because they weren't here the day we handed them out. So I said they're probably on your card. So, how many ways can I distribute 4 identical pencils in a class of 20? 20, C4, perfect. How many ways can a coach select a batting order for her softball team of 9, excuse me. A batting order. 9. I heard 2 things. I heard 9P9, and that makes perfect sense to me because there are 9 players. She's going to choose all 9,
But it's just going to be 9
and the order matters. And that is exactly the same as 9 factorial. So those of you that thought, oh, that's just 9 factorial, you're right. And those of you that thought 9P9, you're right. They're the same number. They equal each other. You're arranging 9 things in a row. 9 factorial. You have 9 kids, you're going to choose all 9, order matters, 9P9. Same thing. How many ways can 4 identical red, 3 different yellow, and 5 identical blues be arranged on a shelf? Have you guys talked about repetitions? How to handle repetitions. Like if you have a word and it has duplicate letters, well, that's what's happening here. That's what's happening. We are going to arrange how many books on this shelf? This is number 4. How many books do we have?
12.
We have 12 books. And when we arrange 12 things, it's 12 factorial. But what about, it's like having 12 letters, okay? But in this case, what about some of these books? They're the same. What do I do when I have 4 identical E's in a word? I divide by 4 factorial. So I'm going to divide by 4 factorial for the red books and 5 factorial for the blue books. I do not divide by 3 factorial because they're not different. I mean, they are different. They're not the same. Now, I'll caution you the same way kids get so sick of hearing me say it, but remember, when you type this into your calculator, anytime there's more than one thing in the denominator, it has to be in parentheses. You will not get the right answer if you don't use those parentheses. Do you know where your factorial button is? It is in the math prob menu along with the NCR and NPR buttons. How many ways can 7 people be arranged in a circle? 6 factorial. Perfect. All right, number 1. How many ways can 3 algebra students and 4 pre-cal students be arranged in a row if the algebra students must sit together? Have you guys done this? Okay, tell me the answer then. 3 algebra, 4 pre-cal in a row, and the algebra ones are together.
5 factorial.
5 factorial. by 3 factorial. Perfect. Now let's talk about where the 5 came from. Where did the 5 come from?
There's like, do you have to group them together?
Well, I have four pre-cal students, right, that I'm arranging. And then I have this group of algebra students. That's 5. That's 5 things. 4 pre-cal students and a group. That's 5 things I'm arranging. And then where did the 3 factorial come from? The group factorial, right? The little bundle that I have, factorial. I love math. How many ways can you arrange these letters? We start with 9 factorial, just like the book problem. How many letters do we have? We have 9 of them. Now, do any of them duplicate?
No.
Oh my gosh, none of them duplicate? No. All right, so the answer is 9 factorial, since nothing repeats. How many ways can first, second, and third place ribbons be awarded in a group of 10? 10 P3, very good. Why is it a P? Order matters, first, second, and third, right? How many 5-card hands contain exactly 3 aces? 5-card hands, 3 aces.
4C3.
4C3, let's stop right there. Where'd the 4 come from?
There's 4 aces.
There's 4 aces, and you are picking 3. 48C2, beautiful. Why 48?
There's 48 cards left.
There are 48 cards that are not aces. If you are picking cards and 3 of them exactly are aces, then that means the other 2 are not. So there are 48 cards in the deck that are not aces, and we're going to take 2 of those and 3 of the aces. How many ways can 10 people be arranged around the dining room table? 9 factorial. Beautiful. Beautiful, beautiful. All right.